Good evening, everyone.
Good evening, sir.
Okay. Let's continue with the questions we were doing yesterday. We were not able to finish all those questions. So today we are going to continue from where we left. So we finished off with question number 7.2. So on question number 7.1, we got an angle of ABC, which is equal to 90 degrees. And on question number 7.2, we were able to prove that AC is equal to K tan Y, all divided by sine X. So then now, we have to finish up with question number 7.3, which say, if it is further given that angle DAC equal to 2x and AD is equal to AC, show that the distance DC between the players at D and C it's equal to 2K tan 1. I think it could be important that I draw this graph or this diagram again for illustration purpose. So we are having a diagram like this. And in the question in 7.2, we were able to show that the distance AC, this distance here, we're able to show that is equal to K tan Y all divided by sine of X. So on the question below, we are given that the angle DAC, this angle up here, we are now told is equal to 2x. And we are also given that the distance AD is the same as the distance AC. So therefore, even this side, we are going to have K tan of Y divided by sine of X. So then now we are required to show that the distance DC, which is the distance between the two players, is equal to 2K tan of Y. So we have to show that the distance DC is equal to 2K tan of Y. So the question is, how do we do that? So we can do that by using what is called the sine rules and the cosine rules. And I believe I've introduced those rules to you at the previous time, but I would like to remind you because that is what we are going to use in order to answer this question. So we can start with the sine rule, of which the sine rule, we must have sine of A divided by A equal to sine of B divided by small b, and then sine of C divided by C, where A, B, C of capital letters are the angles, and then A, B, C of the small letters are the sides. So this A here is the side opposite to angle A. The B here is the side opposite to angle B, and so on like that. And this formula, you can also write it as A divided by sine of A equal to B divided by sine of B, and then C equal to sine of C. You are allowed to write it that way. But there's an important question which we have to answer. of when exactly do we use sine rule. So we use sine rule if we are given two angles and a side and one side to calculate for a side. You can apply the sine rule if you are given two angles and a side, and in this case we should be calculating for a side. We can also be using a sine rule if we are given two sides and one angle. And in this case, we must be calculating for what? For an angle. So this is the information you must know about the sine rule. And now let's go to the information about the cosine rule. So cosine rule, you must use cosine rule which is given as a squared, which is equal to b squared plus c squared minus 2bc cos of a. It's a must that if we are having an angle a here, so a squared must be the subject of the formula in that case. So if we have b squared here as the subject of the formula, so it means b must be an angle there. So it's called an included angle. So in this case, we're going to have b squared equal to a squared plus c squared minus 2ac, and then cos of an angle b. And then same with angle c. So if we're having c squared, it will be b squared. It will be a squared plus b squared minus 2ab, and then cos of c. So these are the three formulas for cosine rule. But the most important question that we must answer, when do we use this cosine rule? We use the cosine rule if we are given three sides while we are calculating for an angle. Then you can apply the cosine rule if we're given three sides, and when you are given three sides, in this case, you must be calculating for an angle. You can also use the cosine rule if you are given two sides and an angle. And in this case, you must be calculating for what? For one side or for a side. So these are two important rules which you must take note of, which they can help us to answer this question that we have on the board. So if you understood what I explained just now, you can tell me exactly which formula are we supposed to use in order to deal with this question we have on the board. Can any one of you tell me which formula can we use to deal with this question we have on the board? Do we have to use sine rule or do we have to use cosine rule? And you can elaborate a reason, or you can give a reason why are we using sine rule? Why are we using cosine rule? Any idea?
The cosine rule.
We have to use the cosine rule. And then what's the reason for using cosine rule?
Because we are given two sides and an angle, and then we have to find the side which is at the distance.
Wonderful. You must have that skill. And I can tell you, let me tell you without any hesitation, that once you understand that information you have given me just now, you can answer any question of this nature. It doesn't matter what kind of diagram you are dealing with. Once you understand this information we have on the board, you can answer any single question, regardless of the kind of graph you will be given. But another thing which you must take note of is that information we have used to find question number 7.2 is very important. You must be able to interpret this graph that you are given there. So you must know the interpretation and you must know how to apply these rules, the sine rule, the cosine rule, and then the area rule. So now you are very right. We have to use cosine rule in this case because it's only when we are given two sides and an angle where we can apply the cosine rule. So it's this second rule that we have. You must be given two sides and an angle in order for you to complete the size. So now let's do the questions. That question just now here. So now, so the side that we are calculating is opposite to the angle A. So it means when the angle A is subject of the formula, when we have angle A as a cos of angle A, then the DC, it must be the subject of the formula. So you must also take note of that fact. So we have DC, which is the subject of the formula. So when DC is the subject of the formula, it means the angle in this case, it must be angle A. So we have DC squared, which is equal to, and then in this case, it's AD squared plus AC squared minus 2 into AD, and then AC cos of angle A. So that is how we can write the formula based on this information that is given there. We are given that this side here is the same as that. Therefore, if you like, you can simplify this formula further, but I would like to work with this formula as it is. So let's just substitute this which we are given, because already I told you the side AD is the same as the side AC. So we're going to have DC squared, which is equal to, and then when we have AD, we substitute K tan of Y, all divided by sine of X squared, plus into K tan of Y, all divided by sine of X squared, minus 2 into, then here we have K tan of Y, all divided by sine of X, and then we multiply this by K tan of Y, all divided by sine of X, which is multiplied by the cos of 2x, the angle. Let's simplify this. We're going to have DC squared equal to, these are the like terms, we can add them together, and we have 2. So these we can also multiply them together, they can have a square. So you can take out the common factor in this case, of which the common factor is 2 K tan Y, all divided by sine X squared. And then when you take out the common factor, here you will be left with 1 minus, and then that side you will be left with cos of 2x, like this. Let me know if we're together up to this step.
No.
All right. I think it's because I've skipped some steps here. Let me rub and write a full step. So I believe this step you understood. Is that so?
Yes.
All right. Then let's take it from there. We're going to have DC squared, which is equal to, we add these two, we're going to give us 2 into K tan Y, all divided by sine of X squared minus 2. These are the same. When we multiply them together, they're going to give us K tan Y, all divided by sine of X with a square, and cos of X. And then we have T squared, which is equal to 2 K tan Y divided by sine X all squared. It's a common factor because it appears here and it also appears there. Therefore, you can take it out as the common factor. You're going to have K tan Y all divided by sine of X squared. And when you take this out as the common factor, you are going to be left with 1. And then when you take it out here as the common factor, then you will be left with cos of 2x, like this. You can use the cal bracket, it's still fine. Is that step clear now?
Yes.
All right. So then now, the next thing is to target that this is equal to exactly what we have here. We must target that this must be equal to 2K tan Y. Otherwise, if we were not given that DC must be equal to this specific, we're going to even end there. No one was going to question us. We're going to introduce the root sides and then we get end there. But now we need to prove that this is equal to. exactly the value that is given there. So the question is, how are you going to get to that step? This is what you're going to do. You're going to take advantage of this cos of 2. So cos of 2x equal to 2 is equal to 3 different equations. So the first one is this one of cos squared x minus sin squared x. So the second one is for 1 minus 2 sine squared x. And then the last one is 2 cos squared x minus 1. So you must choose the one which, when you add with this one, is going to cancel the 1, because 1 is a problem. So it makes this to have two terms. So we want to eliminate this term of 1. So we can eliminate the term of 1 by choosing the correct equation here, of which can subtract with the 1 that we have. Can any one of you tell me which one are we supposed to choose in this case between these three equations? Which one are we supposed to choose which can eliminate the 1 that we have here?
Won't it be 2 cos squared x minus 1?
Yes, that can be a good suggestion. If we're having a positive there, that was going to be the one we're supposed to use, because it was going to be 1 minus 1. But now the problem is this negative here.
So we use the one of sine then.
We use the one of sine. And we can also justify of using this one for sine, because we know the sine squared is going to cancel with the what? With the sine squared down here, because it's not there on the final answer. So therefore the correct one is for the sine, because the sine there, it will also cancel with the sine that we have here. So let's simplify further and see what we will get. So we have this squared equal to 2 into k tan of y all over sine of x squared into 1 minus into, then here when we have cos 2x, we then substitute 1 minus 2 sine squared x, like this. And then we simplify further. So the simplification of this is going to give us 2 into k tan y all over sine of x. And then 1, this negative, it multiplies throughout. So when it multiplies with 1, we're going to have negative 1. And then negative, it will be positive 2 sine squared x, like this. So let me write this side now. So we are going to have dc squared, which is equal to 2 into k tan of y all over sine of x, that is having a square like that. So 1 minus 1 is a 0. So it means we'll be left with a term of 2 sine squared x, like this. And then from there, so we distribute this square here. It can be for the numerator and then for the denominator. And we multiply the 2 here and the 2 there. So it means we're going to have dc squared, which is equal to 2 times 2 is a 4. And then here we're going to have k tan y all squared divided by down here we're going to have sine squared x, and then we multiply with sine squared x, like this. So I believe you can all see that the sine squared, it cancels with the sine squared there. And we then left with dc squared, which is equal to 4 into k tan of y with a square. So after having that, we can then introduce the root both sides. What's the reason for introducing the root? That is for making sure that the root and the square cancels each other. And we now have dc, which is the side of the problem. And then root of 4, it gives us an answer of 2. And then the root, it will cancel with a square, and then you will be left with 2k tan of y. And I know you remember that this is exactly what we were looking for. So DC is equal to 2k tan of 1. So we have used two important rules to deal with these questions. So the first one is the double angle, and then the second one is this cosine rule. So once you apply those two rules, you will arrive to the answer that these guys, they require. Is that clear to all of you? Is that question clear to all of you?
Yes.
All right, wonderful. Can we quickly go to the trig functions?
Yes, please.
All right, wonderful. Let's go to the trig functions. So before I do the questions under trig functions, I would like to give you a small introduction because I remember last time I did not give you any brief on the trig function. So we have three important trig functions which you must take note of. So I will write the general functions of these trig functions. So the first one is sine of x, and then the second one is cos of x, and then the third one is tan of x, like that. So let's plot these three graphs that we are given there. We'll start by plotting the general or the original graph of sine. So I can tell you without any hesitation that the sine graph, the original sine graph, passes through the origin at all times. So we're going to have a graph which is given like this. So this is the sine graph. Sine graph is given like that. And then take note of the fact that this graph of sine, it passed through the origin, like here. And then the second graph, which is tan, it doesn't pass through the origin. So it must have a turning point somewhere up there. So it's going to be given in this form. Let me try to plot it. So here we have 90, here we have 180, 270, and then 360. Same this side, we have negative 90, negative 180, and then negative 270, negative 360, like that. So this is going to be 0 here, and then negative 1 down here, and then 0 there, and then positive 1. So I will use the dots to represent this graph like this. So it must not turn like this. It must be sort of like a curve. And then here we're going to have negative 1 there, and then 0 there, and then 1 up there. So I believe you can see the difference between the the sine and the cosine and the cos graph. So the difference is that this one, it passed through the origin. The sine graph passed through the origin, while the cos graph doesn't pass through the origin. So that is our cos graph. And then the next is the last one. So the behavior of tan graph is different with how sine and cos behaves. So because this one is having what is called the asymptotes. So where do we have the asymptotes of the graph of tan? We have the asymptote at the 90 degree, at the 270 degree, the negative 90 degree, and then the negative 270 degree, like that. So these are the asymptotes. So when you are having a positive value there, so the tan graph is going to be presented in this way. So we're going to have a graph like that. So it goes to infinity here, and then it goes to infinity. It doesn't touch the asymptotes. So same here, it goes this way, and then down here it goes like that. And then this side, you will see that we're just having a portion which goes down, and then similar thing happened this side. So we're going to have this portion that goes up and this other portion that goes down. And here we are just having a portion that goes up. But these portions, they don't touch the what? They don't touch the asymptotes. Is the asymptote of the graph of what? Of tan. So then now, let me tell you, what we have plotted here, these are the general graph for the sine, for the cos, and for the tan. But in most cases, you are not going to be given the general graph to deal with in your questions. So you might have a graph that is shifting upwards, that is shifting downwards, that is shifting to the left, and that is shifting to the what? To the right. So you must be able to deal with the graph that is shifting to the left, to the right, and up to so on. So that is what is called the graph which have shifted or rotated or translated. So they can use three different terms. The first one is the rotation. The second one is translation. And the third one is shifted. So you must understand about all this. So I would like to elaborate on that before we go further. Let's talk about the amplitude first. So how do we calculate the amplitude of these graphs given here? So the amplitude is just the coefficient of this graph. So if we're given a sine graph like this, therefore we have a 1. This one is the amplitude. If the graph was having a 2, so it means our graph will be having an amplitude of what? Of 2. So then now in this case it's 1. So therefore the amplitude of these three graphs is equal to what? It's equal to 1. Because you just have to check the coefficient of this given graph. Are we clear on that explanation I've given just now?
Yes.
All right. That is the amplitude. So it's just the coefficient of the function given. And then the second is what is called the period. So the period of the graph. How do we know the period of the graph? The period of the graph for sine and cos is the same. It's equal to 360 for sine and cos. And then for tan, it's 180. Let me write here. Period of sine and cos is 360. It doesn't change, but I will show you what happens when we have other values there on the period. And then again, the period of tan is given as 180 degrees. But there are factors that influence this period of the graph. What are the factors? The factor is this argument that is given there. So we have an argument of x in this case. If we're just having an argument of x, then the sine and the cos, they will be having a period of 360. And for tan, with an argument of x, it means it will be having a period of 108. But now, let's say we are having this value of an argument divided by certain value. Let's say divided by 8 here, and then divided by 8 there, and then divided by 8 there. So what do we do in that situation? How do we find the period of this graph when it's divided by certain value? So this is how we find the period. So we say the period, which is the original period. So it must then be divided by that value of A, of which this must be equal to the original period. If we're dealing about with the cos and the sine, so it means this must gonna be equal to what? Must gonna be equal to 360. Let me repeat this again. So if we divided this by A like this, in order to calculate for the new period, we are saying the period divided by that value of A, and then this equate with the original period. And then after having that, you can then cross multiply so that 360 multiplies with the value of A, which will be given. And then in that case, this is when you can be able to calculate for the new period. And then there is another situation again, is when you are having sine of AX, instead of dividing, is now multiplying. So we have AX here and BX. Instead of having, okay, let me use A, same value here. So if we have AX, instead of having A divided by X divided by A, so we now have AX. So how do we deal with that situation? So this is how we deal with that situation. So you say A, which is given there, and then you multiply with the new period, and then you equate with the old period. If it is, let me now give an example by tan. If it is tan, so it means this will equate with what? With 180. And then from there, you can divide both sides by A, so that this A and that A cancel each other. You will then get a new period of 180 divided by A. So you will see these calculations when we do questions, because I'm telling you information which is very important about the period. That is how you get the period. And then now let me talk about shifting of the graph. So shifting of the graph, when we are told that the graph has shifted upwards or it has shifted downwards, so the value that is affected in that case, I'm gonna write a new function with a graph that has shifted upwards or the graph that has shifted downwards. So I'll give an example by a sine graph, but it applies to all the functions. So if the graph has shifted upwards, so it means it may have added a certain value, of which in this case I'm calling it value Q. Let's say it has shifted upwards by 1 unit. So it means we're going to say sine of x plus 1, like this. And then if it has shifted downwards by 1 unit, so it means we're going to have sine of x minus what? Minus 1, like that, because it has shifted what? Downwards. So this is the shifting of the graph. If the graph has shifted upwards, we add by that unit. And if it has shifted downwards, we then subtract by that unit. So now I'm going to explain when the graph moved to the left and when the graph moved to the right. That is the critical one, which I want to explain, of when the graph shifted to the left and when the graph shifted to the right. So let's say the graph has shifted to the left by 90 degree. So when it shifted to the left and to the right, it must shift by a degree, not by a unit. It must shift by a degree, because you can see we're given 90, 180, and so on for the x. So when it shifted to the left, this is what you do. I'll give an example by the sine graph, the original sine graph, sine of x. So when it shifted to the left, this is what we do. So we say sine of, then it changed the argument. Instead of having an x, when it shifted to the left, you then have to add by a 90 degree. When do you add? You add when it shifted to the what? To the left. But what happened when it shifted to the right? When it shifted to the right, what do we do? So in this case, let's give an example when it shifted to the right by 90 degrees. Therefore, we're going to have y, which is equal to sine of x. Because it shifted to the right, we must subtract by what? By 90 degrees. I know it might not be. Let me move it like this. So we have to write it like this when it shifted to the what? To the right by 90 degrees. Let me summarize again what I've said. I told you about when the graph shifted upwards or downwards. So you need to add by a unit here. And then when it shifted to the left and to the right, when it shifted to the left, you add by an angle, and then when it shifted to the right, you subtract by an angle. And then I also explained about the period. I also explained about the amplitude. So those are the information which you must understand before answering any question. And I believe I've clarified this to an extent that we can be able to answer any question under a trigonometric function, because that chapter is about this information I explained to you just now. So you can be able to answer as many questions as possible with the information I've given you just now. So let's go straight to the questions so that you see how we answer the question using the
So,
information I gave you just now. So
sir,
I'm like, yes,
before you rub, ne? Before you
all
rub,
right, all right,
in the amplitude,
yes.
can I find the amplitude without being given the equation?
Yes, definitely. You can be able to find an amplitude without being given an equation. Let me give a graph. You must be given a graph in that case. So if we're given this graph, which is a sine graph because it passed through the origin. So if you are given that we have a 1 unit there, so the amplitude, it's simply at the height of the graph from the origin to the top of the graph. That symbolizes the amplitude. And the amplitude cannot be negative. It must be positive at all times. For example, here, when we measure this distance to the turning point, you will see we're having a negative value there. So, but the amplitude, it must be positive of that value. So the amplitude, it would be 1 in that case, of which you can read when you are given the graph. So you can read the amplitude if you are not given the function. You can read it from the graph. Is that clear?
Yes.
All right. Is there anyone who have a question before we go to doing problems that may apply exactly the same knowledge that I gave you just now? Can we go to the questions? All right, let's go to the question. That's where you will see that what I was telling you can assist in answering as many questions as possible under trig functions. So I would like to answer the questions you gave me the last time. All right, is question number 6. So is there on our WhatsApp group. And this question talks about a graph or a function of f of x, which is equal to cos of 2x. All right, before I even go further, you guys, with the information I gave you, you must be able to tell me what is the amplitude of this graph? What is the period of that graph? Is this graph shifted to the right, to the left, downwards or upwards? You must be able to tell